Hey guys, this is 7-6. It's factoring higher degree polynomials. Um, we are working on, in this section, polynomials that are degree 3 or more, and not just quadratics. You've factored lots of quadratics in your life, and you will do lots more, but um, this is about how do we factor stuff that's more than quadratic. One way you can do that is with a sum or difference of cubes. And we'll actually learn in a minute that you can do a sum or difference of any power as long as it's odd. It's not going to work for even power. That's why you can't do a sum of squares. But as long as they're both odd, you can do a sum and difference big as they are. Another possibility for factoring a cubic is by grouping. For instance, here we could factor an x squared out of the first two terms and be left with x minus 2. And then I could factor a negative 3 out of the second two terms and be left with x minus 2. And just coincidentally, they both happen to have an x minus 2. And then my factored form would be x squared minus 3 times x minus 2. And if you FOIL that back out, you can convince yourself that these two things are exactly the same. Now that's a very select few cubics that will factor by grouping. And the only way that usually is going to happen is if somebody who made up the question made it that way. So we need to figure out how do we factor cubics or fourth degree quartics or quintics. How do we factor higher degree polynomials? How do we break them down if grouping won't work? So our first example, this is called the Factor Theorem. And in pre-calc, you might do a more difficult version of this where you list out all of the possibilities for the factors and find them the old-fashioned way, but we've got calculators, so we're going to use them. Here it is, and as simple as I can make it for you. 3x cubed minus 2x squared minus 7x minus 2. And our goal is to factor this cubic polynomial. We're going to do this by graphing it. I've got in my calculator that same equation stored, and I want to go to the graph of that equation. So here's its graph. And to get a little bit better picture, I want to zoom in once. And I'll zoom in, I'll move it a little bit to the right and then zoom in here. So I can see the x-intercepts of my function. Now, to figure out what those x-intercepts are exactly, I want to calculate my zeros. I assume that this first one is at -1, and the second one is somewhere between -1 and 0, and that my third one is at 2. But just to confirm those, especially the one that's between -1 and 0, I'm going to use the second trace, which is the calc menu, and I want to calculate a 0, so option 2. So left bound means put in any number left of my suspected 0. Or you can scroll with your cursor all the way over till you get to its left. Here comes my cursor. I want to get to the left of the 0 and hit enter. And then I want to go to the right of the 0 and hit enter. And then it asks me for a guess just to help it get started. And it turns out that that 0 was in fact -1, which is what I thought it was anyway. For this next one, I'm going to start over. I'm going to calculate a 0. For left and right bound, those are numbers you can enter. I know that this one is between -1 and 0, so my left bound can just be -1, enter. My right bound can be 0, enter. And I'm guessing that it's like -0.4. So I'm just going to put that in as a guess, and we'll see what I get. And then I actually get -0.33333, which you need to know that that's -1/3. So that's a rational number, -1/3. My final one is going to actually be right at 0. Just one more time, calculate a 0. I know that it's somewhere between 1 and 3, so my left bound is going to be 1, my right bound is going to be 3, my guess is 2, and in fact it does cross right at 2. So scroll with your cursor to do left and right bounds, enter them however you want to do it, but you need to be able to find zeros in your calculator. So my zeros are -1, -1/3, and 2. Okay, so what does that have to do with factoring? -1, -1/3, and 2 are the three values that make this cubic polynomial equal to 0. There's a connection here between zeros and factors, and that's the factor theorem. It's very easy to factor once you know the zeros. Basically, what the factor theorem says is this. If a is a 0, then x minus a is a factor. All right, this is just like when you would either factor or do the quadratic formula to solve a quadratic equation. You're doing the same thing here. The connection between factors and zeros is a very simple and strong connection. So what I know is that two of my factors are x plus 1 and x minus 2. Okay, get out of here. X minus 2. Now, those I can do because a is an integer. So any integer values of zeros that you find in your calculator, you can turn them into factors by doing x minus them. So the negative zeros become x plus and the positive zeros become x minus. Now, what would be really cool would be, what if I just go x plus 1/3? That, not so fast. I cannot do that with rational zeros, as in fractions. Okay, I can't do any of this if it's not a rational number, if it crosses at some weird decimal number. If it crosses at a rational number like -1/3, I'm going to have an option here, but it's not x plus 1/3. So what do I do about a rational zero is my next question. And I lost my thin line. The counterpart to the factor theorem is called the rational root theorem. And it tells you what do you do if your zero is at a rational number, at a fraction, instead of at a whole number. And here is the rational root theorem. If b over a is a 0, then ax minus b is a factor. Okay, so what that means is I can't just do the x plus 1/3 like I wanted to earlier. Instead, I have to transform it a little bit, and I'm going to have my same two factors as before, but my third factor is going to be 3x plus 1. So think of my 0 of -1/3 as b over a, -1/3. So b equals -1, a equals 3, and then my factor is ax minus b. So 3x minus -1, or 3x plus 1. Okay, so that's the rational root theorem. And what this allows us to do is factor any polynomial as long as its zeros are either nice integer numbers or nice rational numbers. We can deal with any of that. We can't deal with irrational numbers in this way, but we're good for anything other than that up till now. Okay, so let's do another example where something slightly different might come up. Let's factor 2x cubed minus x squared minus x minus 3. Okay, so it's cubic. I don't think any of the grouping is going to work, so I turn to the factor theorem, or the rational root theorem, which basically says find the zeros, which we are going to do via calculator, and one of your evil pre-calc teachers will make you do in another terrible way. But that's not me. I'm way nicer than them. So 2x cubed minus x squared minus x minus 3. So let's graph this thing and see where it crosses. Now zoom is still set to the other problem. So let me go zoom 6 to get a 10 by 10 window. Now this cubic, it comes up and it turns back down, and then we have one x-intercept. So let's see where that x-intercept is. Let me zoom in on that intercept. Uh-oh. Clear. Zoom in. Okay. So I am anticipating that that's at 1.5 or 3/2, but let me just make sure. Second trace, option 2 for a 0. I know it's somewhere between 1 and 2, so those are going to be my left and right bounds. And my guess is going to be 1.5. And in fact, it is 1.5. So it's a rational root. So this thing has 1, 0, and it's at 3/2. Think of it as 3/2 instead of 1.5. Now, we've learned that any cubic should have 3 zeros. So think about what that means for the other 2 zeros. They didn't show up on the graph, so that must mean they are, say it with me, imaginary zeros. It's got to have them, but they're just not going to show up on the graph. So what I know is that this original question, this cubic polynomial, is going to factor. And by the way, 3/2 turns into a factor of, think about it, what is it? Rational root theorem. 2x minus 3. And there's got to be another factor. Remember, when you're factoring, you're not solving an equation. You're just breaking something down. Like breaking down the number 8 into 4 times 2. You're just breaking it down into the things that would multiply together to give it to you. So I know that 2x minus 3 is a factor because of the rational root theorem. So what is left over? To figure out what's left over, we need to divide. If I tell you that 2 goes into 50 and ask you what's left over, you do 50 divided by 2 equals 25. So if I tell you that 2x minus 3 goes into this cubic, to figure out what's left over, you divide 2x minus 3 into 2x cubed minus x squared minus x minus 3. So I'm going to, through the magic of technology, save us some video time, because I wouldn't want you to have to watch a long video. I'm going to pause and resume in just a second. Okay, so there's your long division. And notice one thing about this is that the remainder was 0. You better get a remainder of 0 or else you have a problem. Because having a remainder of 0 means it divided in equally. And by saying that 2x minus 3 is one of the factors, we are saying that it divides in equally. So if you did not get 0, either 2x minus 3 was a wrong factor, or you did your long division wrong. But what I've done is I've determined that x squared plus x plus 1 is what's left over when I divide out 2x minus 3. All right? Now, my last question on this example is, why don't I go ahead and break down the x squared plus x plus 1 part into 2 new parentheses, like this? Think about that answer. Why don't I do that? Pause if you want to keep thinking about it. And the answer is, it's not going to factor. It won't break down anymore. If it would have broken down more, then I would have had more zeros on my graph. But I didn't have more zeros on my graph. I only had one nice rational 0, so therefore I only have one linear factor. My other 2, if I were to go ahead and solve that and get the imaginary answers, that would be my other 2 zeros, the missing link 2 zeros that I talked about a minute ago. So, how do you factor a cubic like this? Find the 0. It's either going to be 1 or 3 zeros. If it's just 1, do long division like I just did here, and the remaining quadratic is the other factor. Sometimes you have 2 nice factors, sometimes you have 3. going to leave that one thing I was telling you about the sum and difference of cubes and fifths and sevenths and all that. I'm going to leave that for a minute, or leave that for in class, and just review. The factor theorem and the rational root theorem, that's our main things today. The thing you need to remember is that if a is a 0, x minus a is a factor. If b over a is a 0, then ax minus b is a factor. And if you only get one nice one, do long division to get the other one, and it won't be nice. All right? Well, we'll go over anything else you need to know in class. All right, so I hope you enjoyed one of my favorite sections, the factor theorem. Young out.